we're gonna discuss the type 4 of our absolute inequalities. You may refer to your lecture notes on page 16. We have covered 3 types of absolute inequalities in our previous videos. So now, this is the type of absolute fractions that we can see in our inequalities. The only method that we can use to solve this type is by using the basic definition method. Please recall that we need to make sure that we have only single absolute on our left hand side of our inequality before we can apply goal. Let's look into example 14. Solve the inequalities for modulus 10 minus 2x over 3x plus 1 is greater than 1. In this case, we can see that we have the fractional absolute that we have on our left side of our inequality. So we can apply type 4 of our absolute inequality solution. So we can use the method of basic definition to solve these questions. Now we can see that we have the single absolute on our left side of inequality. So we can apply goal. In this case, we can see that this is the sign of greater than. So we can split our solution with or. So for the positive one, we have 10 minus 2x over 3x plus 1 is greater than 1. Or for the negative part, we have 10 minus 2x over 3x plus 1 is less than negative 1. So we need to solve them separately for both sides. Next, I want to start with the left side of our inequality. The number 1 that we have here is we need to bring them to the left side. So we can have 10 minus 2x over 3x plus 1 minus 1 is greater than 0. We need to make sure that the zeros can be in our right side of our inequality. So we have here 10 minus 2x minus 1 times with 3x plus 1 over 3x plus 1 after we equate the denominator so that we can have the single fraction on our left side inequality. After you simplify it, we can have negative 5x plus 9 over 3x plus 1 is greater than 0. To find the solution for our left side inequality, I want to use the table of sign method so that we can find the solution. In this case, we can see here that I'll put the critical values that we have here, negative 1 over 3 and 9 over 5, by solving the fraction that we have on our left side of our inequality. So, this is the critical numbers. The interval that I have here is from the negative infinity up until negative 1 over 3, and then from negative 1 over 3 up until 9 over 5, and from 9 over 5 up to infinity. All of them will be the open interval since the sign that we have here is greater than. Now for the value of x, we can choose any value that we have in the correct interval. So I'll choose negative 1, 0 and 2. For the factors that we have here, negative 5x plus 9 from our numerator of our fractions, we can have the sign of positive. And for this interval, we can have positive, and then for the last interval, we can have the negative sign. Do the same for our denominator factor, which is 3x plus 1. So we can have negative after you substitute the value of negative 1, 0 and 2, so we can have the positive and the positive sign. As the conclusion, please recall that we need to divide by the factors of negative 5x plus 9 over 3x plus 1. So we have in this interval positive over negative, which is negative. So for this interval, do the same. Positive over positive is positive. And then for our last interval, we have negative over positive is negative. After that, we need to make sure that which region that we need for our solution. In this case, we can see here that we need for the greater than 0. It means that we need the positive region. That's why I choose the positive region. So the answer for our left side would be inequality would be in this interval, which is -1/3 up until 9/5 open. Now we can move to our right side of inequality. So we have here 10 minus 2x over 3x plus 1 less than -1. To solve for this inequality, we need to bring the -1 to our left side. So we have 10 minus 2x over 3x plus 1 less than 0. So now we have 0 on our right side of inequality. Now we can equate the denominator so that we have the single fraction of our inequality with x plus 11 over 3x plus 1 less than 0. Up until this stage, now we can apply the table of sign method to solve our inequality. So this is the table of sign that we can construct by using our inequality. We can have the critical numbers here by solving the fractions that we have. So x plus 11 will have the critical numbers of -11. Another one is for our denominator, we have 3x plus 1 equal to 0, so that we have x equal to -1/3 as our critical value. So the interval that we can have here is from -∞ up until -11, -11 up until -1/3, and from -1/3 up until infinity. So the value of x that we can choose here is any value that's suitable in our interval. So I choose -12, -1, and 0. Now we need to check the sign for each of our factors that we have. So for the factor x plus 11, the sign would be negative for our first interval, positive for our second interval, and positive for our last interval. Do the same for the next factor that we have on our denominator, which is 3x plus 1. So after you substituting the -12 into our factors, you will have negative. Substituting the -1 into the factors 3x plus 1, you will get negative. And substituting 0 into our factors 3x plus 1, you will get the positive. Now for the conclusion, we need to divide the sign of the factors x plus 11 over 3x plus 1. So we have negative over negative, which is positive, positive over negative, which is negative, and positive over positive, which is positive. So for the answer for our right side would be the sign of less than 0. Hence, we choose this region, which is for the interval of -11 up until -1/3. We are not done yet. We still need to combine the answers from our both sides. Please recall that the answer for our left side is -1/3 up until 9/5, and the answer for our right side is -11 up until -1/3. So we need to combine them by using the OR. So we need to draw the line number so that we can have all the numbers on our line number. So we have -1/3, 9/5, and -11. So we need to write them in ascending order. So we have -11, -1/3, and 9/5. So for the answer for our left side is from -1/3 open up until 9/5 open. Now the answer for our right side is -11 up until -1/3 open. By considering the OR, so we need to consider the union. So we need to cover all the region that have the lines. So it is the region of from negative 11 up until negative 1 over 3, open, union with negative 1 over 3 up until 9 over 5, open. Or we can write in this form.